For today's lesson, we will be discussing about the sum and difference identities. So last time, we already discussed some of the few trigonometric identities. We have the reciprocal identities, we have the quotient identities, and we also have the Pythagorean identities. So this time, what we will be having is the sum and difference identities. We will also be discussing here the double angle identities. So we will be trying to solve different trigonometric functions using the following identities. So let's start with the sum and difference identities. So I just have here four sum and difference identities. So we will just focus with the sine and the cosine. So with sum and difference identities, you have here two angles, and let's say we want to add or subtract the angles, and we want to identify the sine and the cosine. So these are the things that we have to use. So let's start with sine. So we have sine of a plus a b and sine of a minus a b. So these two right here. So if we want to get the sine of a plus b, what we will do is to get the sine of a, multiply it to cosine of b, then add it to the product of cosine a and sine b. So the pattern for sine of a minus b is the same. The only difference is the sign that we use. Since this one is negative, so we will be using negative here also. Now for cosine of a plus b and cosine of a minus b, what we will be having is cosine of a times the cosine of b. And for the operation, you just have to get the opposite. So if it's addition here, then the operation that we will use is subtraction. If it's subtraction, then the operation that we will use is addition. And we also have to get the product of sine A and sine B. We also have what we call as the double angle identity. So this is where we want to multiply the given angle by 2, and we want to get the sine and the cosine as well as the tangent. But in this case, we don't know the angle itself. So that's why we will be using this identity. So if we want sine of 2a, so that will be 2 times sine a times cosine a. If we want to get cosine of 2a, that will be 1 minus 2 sine squared a. And tangent of 2a is 2 tangent a over 1 minus tangent squared of a. So later you will see in the different questions, you can already identify what identity to use, because you can clearly see if it's for double angle or for sum and difference identity. Another thing that we have to remember is that the sign of our trigonometric function differs for every quadrant. Our angle can be located in different quadrants. It can be in quadrant 1, 2, 3, or 4. It depends. Now, the location of the angle affects now the sign of our trigonometric functions, because these trigonometric functions came from the x and y values in our quadrants. So as you remember, for quadrant 1, x and y are both positive. For quadrant 2, x is negative and y is positive. For quadrant 3, both of them are negative. And for quadrant 4, x is positive, y is negative. So these values affects the sign of our trigonometric functions. So you have to remember what will be the sign of each function for different quadrants. For example, if I'm getting the sign of an angle located in the 4th quadrant, so that means the sign of that is negative. Okay, so we will be using this concept later on as we go through with the discussion. So let's try to solve this, given cosine of alpha, which is 3 over 5, and sine of beta, which is 12 over 13, where alpha lies in quadrant 4 and beta in quadrant 1. Find cosine of alpha plus beta and sine of beta minus alpha. So in this case, as you can see, what we want is the sum and also the difference of our two angles. And to do that, so let's write the formula for cosine of alpha plus beta. So cosine of alpha plus beta is equal to, so we're following the pattern cos, cos, sin, sin. So cosine of, then you write alpha, cosine of beta, and since this is cosine, we will get the opposite of the operation, which is subtraction, and then sine of alpha, sine of beta. Now, looking at the given formula, what we need is also the cosine of beta and also the sine of alpha. But what we have here is just the cosine of alpha and sine beta. So what we will do is we will try to solve for the missing functions using the one that we have. So let's start with cosine of alpha. So let's write here, cosine of alpha is 3 over 5. Now going back to SOHCAHTOA, we know that we can solve for cosine if we know the adjacent side and the hypotenuse. So it's dividing the adjacent by the hypotenuse. So let's apply that concept here. So if cosine of alpha is 3 over 5, that means the adjacent side is 3 and the hypotenuse is 5. And from this, let's try to draw a right triangle. So you draw a right triangle and then let's label this angle as alpha. Now, since we know the measure or the length of the sides, so we have 3 as the adjacent and we also 5 as the hypotenuse. From here, we can use now the Pythagorean Theorem and then solve for the missing side. So since this is 5, this is the 3, you get the square of 5 and then subtract the square of 3, that will be 16, and then get the square root, so we have 4 as the opposite side. So again, to get 4, you just have to apply the Pythagorean Theorem. Now that you already have the missing side, we can now actually solve for the sine of alpha. So going back to SOHCAHTOA, sine can be solved by dividing the opposite side and the hypotenuse. Since we already know that the opposite side of the alpha is 4, so we can write here 4 over the hypotenuse, which is 5. So what we have for the sine now is 4 over 5. But we have to remember our alpha lies in the 4th quadrant. And from the figure that I showed you a while ago, if the angle is in the 4th quadrant, then its sign should be negative. So you just have to write here negative. So therefore, the sine of alpha now is negative 4 over 5. So we will use this information later on to solve for our function. So next thing that we will be doing now is to identify also the cosine of beta. So let's use now sine of beta. Sine of beta is equal to 12 over 13. So let's use the same concept that we did here, but this time it's now sine. So 12 is the opposite and then 13 is the hypotenuse. So you draw again a right triangle and then let's label this angle as beta. So the opposite side is 12, the hypotenuse is 13. From here, we can get the measure of the adjacent side. So you get the square of 13, and then you subtract the square of the opposite, which is 12. You'll get 25, get its square root, so that will be 5. So that means the adjacent side of the angle beta is 5. Now after that, we can now get our cosine of beta. So cosine again can be solved using adjacent over hypotenuse. So adjacent is 5 and the hypotenuse is 13. So since beta is in the 1st quadrant, all of the trigonometric functions is positive. So therefore, cosine of beta is 5 over 13. Now, since we already have the complete information that we need, we can now substitute the values to our equation and then simplify. So, cosine of alpha is 3 over 5, cosine of beta is 5 over 13, minus sine of alpha is negative 4 over 5, and sine of beta is 12 over 13. And then all you have to do now is just to simplify. So this is 15 over 65 and then negative. So this will become positive 48 over 65. And then all you have to do is to add. So we have 63 over 65 as the final answer. So that will now be the value of our cosine alpha plus beta. So for the next one, sine of beta minus alpha, so we will be doing the same thing. So let's write first the formula. Sine of beta minus alpha. Now if you notice in our formula, it's always a plus b or a minus b. If it happens that the question is like this, all you have to do is just to interchange the angles. So since it's cosine, so it will follow the format sin cos, cos sin. So sine of, then you write beta, cosine of alpha, and then follow the operation, so minus cosine of beta, sine of alpha. Now that we already have the values, we can already substitute here. So we have sine of beta is 12 over 13. Cosine of alpha is 3 over 5. Minus cosine of beta is 5 over 13. And sine of alpha is negative 4 over 5. And then just simplify 36 over 65. So then this will be plus 20 over 65 as well. So if you add the numerators, that will be 56 over 65. So this is now the value of our sine beta minus alpha. So that's how you do it with the sum and difference identity. So you have to identify first the missing functions, and then you have to take note where the angle is, what quadrant, and then substitute, simplify. Next, let's have this. Given sine of t is equal to 3 over 5, and t, which is our angle, is greater than pi over 2 but less than pi, find sine of 2t. So from the problem, you notice now that it involves double angle. So what we will do is, let's write first the formula for the double angle of sine. So sine 2t. T is just the angle. So we have 2 sine of t cosine of t. So in order for us to solve for sine 2t, we need to have the value of the cosine of angle t. And to do that, since what we just have here is the sine of t, we will be using the same technique that we did with the previous example. So let's write here sine of t is equal to 3 over 5. Now since this is sine, therefore 3 is the opposite side, and then 5 is the hypotenuse. So by drawing also another triangle, we can identify the adjacent side. So let's say this is angle t, opposite is 3, the hypotenuse is 5. So that makes now our adjacent side equal to 4. Again, just use the Pythagorean Theorem. Now, to get the cosine of t, so cosine can be identified by dividing the adjacent and the hypotenuse. So we have now 4 over 5. But one thing that we have to remember is that our angle, which is t, is between pi over 2 and pi. So that means our angle is in quadrant 2, because if you remember, if we will draw Cartesian plane, so this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. If it's greater than pi, so that means it should not be in the first quadrant. So it should be somewhere here. Now, it's less than pi, so that means it should not be higher than 180. So that means our angle is at this place, or second quadrant. Now, if the angle is in the second quadrant, that means the cosine should be negative. So what we will put here is negative 4 over 5. So this will now be the cosine of angle t. And then, again, just substitute here. So 2, then sine of t is 3 over 5. Cosine of t is negative 4 over 5. Multiply everything. So 2 times 3 times negative 4. So that will be negative 24 over 25. So that will now be the sine of 2t. For our next example, if tangent theta is equal to negative 1/3 and secant of theta is greater than 0, find cosine 2 theta and tangent 2 theta. So we will be doing the same thing. So we have to write here first the formula for the cosine of 2 theta. So cosine of 2 theta, this is double angle, so that will be 1 minus 2 sine squared theta. Now what we only have is the tangent. So what we will do is we have to identify first the sine so that we can identify the cosine of 2 theta. So let's use now the tangent. Tangent of theta is equal to negative 1 over 3. Now, if you're going to analyze the tangent, it will be a bit difficult if we will be using the triangle, because we still have to identify which of the following. Is it the numerator, the denominator is negative? So, what we will do is we will be using another technique in identifying the sine of the given theta. Take note, the tangent can be solved by dividing the sine and the cosine. So that means these values here, the 1 and 3 is already the sine and also the cosine. So we have 1 is our sine of theta. We have 3 as the cosine of theta. So if I'll write here, sine theta is equal to 1, cosine of theta is equal to 3. But the question is, which one of them is negative? Remember, secant of theta should be greater than 0. And if it's greater than 0, that means it should be positive. Now, you have to identify which among the two, sine or cosine, is related to secant. So, as what we know, cosine is the one that is related with secant because they are just reciprocal of one another. So, whatever the sign of secant is, that should also be the sign of our cosine. Because if you're just getting the reciprocal, you're not changing the sign. So, if secant of theta is greater than 0, that means cosine of theta should also be greater than 0. That means it should be positive. Therefore, sine now is the one that is negative. So, we have sine of theta which is negative 1. Now that you already have the sine of theta, you can now substitute here. So, 1 minus 2. Then, sine squared theta is just the same as sine theta squared. So, you have negative 1 and then square. So, 1 minus 2 times 1. 1 minus 2. This will give us negative 1 as the value of cosine 2 theta. Now, for tangent 2 theta, we will be applying the formula tangent 2 theta. So, the formula here is 2 tangent theta over 1 minus tangent squared theta. And since we already have the tangent, which is negative 1/3, so we can just substitute here. 2 times negative 1/3 all over 1 minus negative 1/3 and then square this. So, for the numerator, it's negative 2/3 all over 1 minus, then the square of negative 1/3 is 1 over 9. So, we have negative 2/3 over 1 minus 1 over 9 is 8 over 9. Since this is now a complex fraction, so you'll get the denominator and multiply its reciprocal to the numerator. So we have negative 18 over 24. Or if we simplify this, this will be equal to 3/4. So you just have to divide negative 3/4. Just have to divide both of the numbers by 6. And then that's it. This is now the value of tangent 2 theta. So again, that's how you do it with the double angle. You just have to again identify the missing function, whatever is needed in our formula, and then simplify. Now for our last example, you might be wondering how are we going to get the sine of 135 degrees? And 135 degrees is not a special angle. Because if an angle is a special angle, we can easily identify the sine, the cosine, and so on. But in this case, what we have is sine of 135. And how are we going to use the identities and able to identify the exact value of this particular value? So what we will do is we can separate 135 into two different angles. So we can say sine of, so you think of two numbers that when you add, the answer is 135. Most preferably, let's use special angles. So we can use 45 and 90. So 45 plus 90 degrees. So as you can see here now, it becomes now a sum of two different angles. And if you'll go back to the identities, we can now apply here the sum and difference identities. So it's now like sine of A plus B. So here, what we will do is we can expand this. So sine of 45 degrees times cosine of 90 degrees. So again, this is sine of A plus B. So sin cos, cos sin, plus cosine of 45 degrees times sine of 90 degrees. And since these are just special angles, so we can easily identify their values. So let's substitute here the values of each. So sine of 45 is square root of 2 over 2. So let's write square root of 2 over 2. For the cosine of 90, it's 0 plus cosine of 45 degrees is square root of 2 over 2 again. And for the sine of 90, it's 1. And then just simplify this. So this is now 0 plus square root of 2 over 2. Or if we add, we have square root of 2 over 2. So this is now the exact value of the sine 135 degrees. So if you see that the angle is not a special angle, so you can do this. You can separate the angle into two different angles and you can apply the sum or difference identities. So that's it for today. I hope you learned something about sum and difference identities as well as the double angle identities, and see you next time.